It is so hot. It feels like staying in a greenhouse. Let me turn on the air conditioners.
Hold on. Using too much air conditioning will turn the Earth into a giant greenhouse. According to the statistics in 2020, air conditioning accounts for the highest proportion of all the electricity consumption in Hong Kong. Electricity consumption leads to carbon emissions. With the greenhouse effect, the Earth gets hotter. The room gets hot because sunlight carries radiation energy and enters the room through the windows. Objects in the room absorb sunlight and get warmed up. Instead of relying entirely on air conditioning, why don't we try to reduce the sunlight entering the house? For example, sun control window film is a good energy-saving tool. By putting it on the window, we can stop some of the radiations from entering the room. The indoor temperature is thus lowered.
Dr. Tong, I heard that there's a sun control window film which can reduce the amount of sunlight entering the room so we can use less air conditioning. The solar heat gain is then reduced. It sounds amazing.
You are here just at the right time. I've got some sun control window films here.
What are these?
These sun control window films have different transparencies.
Some are more transparent while some are less transparent. Is it better to reduce heating with lower transparency?
If you want to know how they work and the relationship between transparency and their effectiveness of thermal insulation, we can do some experiments. Here are several foam boxes. We will put the sun control window films on the glass. They will then be put on top of the boxes and the setups will be exposed to direct sunlight. A Bluetooth thermometer is fixed inside each box. The temperature changes are recorded in the tablet. If the interior temperature increases, the data can be captured instantly. We aim to record how solar radiation heats up the interior of the boxes. We wish to reduce other heat transfer mechanisms. That is why we use the foam boxes. Foam boxes are good thermal insulators, which can reduce heat transfer by conduction. When the boxes are covered by these glass plates, the air is trapped inside. It can reduce heat transfer by the convection of air. A metal plate is placed at the bottom of each box to increase heating by radiation. The plates are painted black. That makes it more effective in absorbing sunlight. The warmed plates will heat up the air inside the boxes. We can then see the heating effect of sunlight.
Sure, let's take them out.
Hold on! Doing the experiment well requires some essential skills. First, the test has to be fair. The boxes are identical. The thermometers and the metal plates should be placed in the same position in each box. When exposing them to sunlight outdoors, we should ensure that they have the same orientation. The boxes should be put in the same place to avoid large differences in the initial conditions. This is why we should cover the boxes with foam lids so that they don't get heated up before the experiment begins. The lids are then removed at the same time. The test is fair in this way.
Oh, we should be so cautious. Let's take them outdoors carefully.
Okay. It's ready now. We have 4 boxes. The glass plate on this box is not equipped with sun control window film. This is because we want to compare between setups with and without the film. It's called a control experiment. When compared with a setup without film, the effectiveness of the film can be clearly observed. This one is equipped with film of higher transparency. This one is also equipped with a film but of lower transparency. The lid of the last box will not be removed so that sunlight cannot go into the box. In this way, we can test whether there are other mechanisms apart from sunlight that can heat up the boxes, such as conduction and convection. It is another control experiment.
By using a control experiment, we can test the importance of the factor concerning us and any effects of other factors. How long will this experiment take?
Since heating by sunlight is quite rapid, 10 minutes is more than adequate. Let's count down and take away the lids together.
Sure.
1, 2, 3. It's been 10 minutes. Let's see the result. Take a guess, which box is the hottest and which box is the coolest?
The one without the film should be the hottest for sure, because sunlight enters directly.
Bingo! This one is indeed the hottest. Which one is the coolest then?
Is it the one with the lowest transparency?
It is the fully covered one, because sunlight cannot enter. It is heated up in other ways, such as conduction. The temperature rise is thus the smallest. More sunlight entering results in a larger temperature rise. When comparing the setups with and without the film, the temperature difference is as large as 7 to 8 degrees Celsius. But for the films of different transparencies, the temperature difference is only 1 to 2 degrees Celsius. Still, the one with a higher transparency is much hotter, as we can see from this graph.
There's a saying that if the window faces west, the room is usually hotter in the afternoon. It's because they haven't applied sun control window film. The sun shines on the house directly, it becomes very hot.
In tropical areas like Hong Kong, the heating effect inside your house due to sunlight is significant. If your house faces west, using sun control window film will make a huge difference.
Dr. Tong, what if I make a sealed room, just like the covered box in the experiment? We seal all the windows so that no sunlight can enter the house. The indoor temperature would be lower. Then we could rely less on air conditioning in summer and save electricity bills.
It doesn't work that way. If all the windows are sealed, poor ventilation would affect our health. Moreover, it is not desirable to have a dark room. Letting natural sunlight come in, we can enjoy the view. With better ventilation, life becomes more relaxing. We can even use less lighting and save on electricity bills.
That's right, a sun control window film really helps.
We will carry out an experiment to test the transparency of different films.
Let's do it.
Sure.
I'm ready. Why are you still playing with your smartphone?
I'm not playing. I'm setting up the smartphone for the experiment. Smartphones are very advanced nowadays. They are equipped with many sensors. Using suitable apps, we can measure many different things. For this experiment, we will measure illuminance with a light sensor. Illuminance represents how bright a surface is illuminated by sunlight. The unit is lux. The smartphone will be placed at the bottom of the box. The glass plates are equipped with different films and are placed onto the boxes in turn. We will see the illuminance measured by the smartphone. Let's begin. Without a glass plate, what is the reading?
About 44,000 lux.
Let's place a bare glass plate on it now. The reading is about 40,000 lux. Let's use a glass plate with a sun control window film of higher transparency. What is the reading now?
About 31,000 lux.
You can see the difference in illuminance with and without the sun control window film.
The difference is obvious.
Now let's try with the film of lower transparency. It is darker. What's the reading?
About 16,000 lux.
We can calculate the transparencies of the films. We had the reading with bare glass and the readings with the films. Dividing the reading with the film by the reading with the bare glass, the transparency of the film can be calculated. According to the manufacturer, the transparency of this film is about 70%. The transparency of the other film is about 40%. You can compare the data from the calculation with that given by the manufacturer.
Now we know the transparencies of the films. If I want to make the room brighter while saving energy, which film should I choose?
When choosing which film to use, you should consider the purpose and the direction of your room. If you want it to be brighter, like a study, you should choose the one with a higher transparency. If your room faces west and you want it to be darker and cooler, you should choose the one with a lower transparency. It all depends on the purpose. According to the test on temperature change, the temperature difference between the two films is small, just about 1 to 2 degrees Celsius only. but the transparency of this one is smaller. How do you make a decision? No matter how we choose a film, we wish to make the best use of it. We need to strike a balance to make the best decision.
Yes, we should think thoroughly and achieve a balance between different factors. That's wisdom.
Exactly. What are you doing with the sun control window film?
Dr. Tong, these sun control window films block part of the sunlight and save air conditioning. It would be great if we could use the blocked energy. That's killing two birds with one stone. Isn't that a good idea?
Tissue, that really is a brilliant idea. Did you know many scientists and engineers are currently working in this direction?
This film is so special. What is the secret?
It is not an ordinary film. It is a thin film solar cell. Besides blocking some of the sunlight, to lower indoor temperature, it can convert sunlight into electricity. That's killing two birds with one stone.
It is thin, light and flexible. Can it really generate electricity?
Of course. Try to connect it to the motor.
Is it real? See if the motor rotates.
It is rotating so fast.
It is getting faster. That's incredible. I'm ready. How do we do this experiment?
We will test the ability of the thin film solar cell to reduce incoming sunlight and its effect on indoor temperature rise.
Should I put it right here?
Not this large. I've prepared a small one. Fix it on the glass and put them on the box. Another box is used for a control experiment. There is no thin film solar cell on it. After my countdown, let's take the lids away together. Then we wait for 15 minutes and keep them exposed to sunlight. We will record the temperatures and see how they change.
Sure, I'm ready.
1, 2, 3. I have got the data. The temperature without the thin film solar cell is almost 40 degrees Celsius. The other one is only 34 degrees Celsius. The difference is about 6 degrees Celsius.
The difference is significant. We have measured the indoor temperature. Let's also test the illuminance.
Okay, we use only one box this time. The smartphone will be placed inside the box. The thin film solar cell is placed on the top together with a bare glass plate. We will compare the data. Let's put the smartphone in and then cover it. What is the reading? About 6,200 lux. Now, we put on the bare glass plate without the thin film solar cell. What is the reading?
About 27,000 lux.
A great difference. It shows that the thin film solar cell blocks most of the sunlight. The transparency of this thin film solar cell is quite low. Different thin film solar cells can have different transparencies. One may have a film with higher transparency but lower output power. Another one may have lower transparency, like this one, but higher output power.
Oh, so it's related to its transparency.
Yes.
The thin film solar cell brings a lot of benefits. Why don't we use it everywhere?
It is a rather new technology. Compared with traditional solar panels, its development is not mature enough yet. The lifespan is shorter, but the development cost of a new technology is high. Hence, it is not widely used yet. However, with the rapid development of technology, it is believed that these thin film solar cells will become more popular. The development of such new technology requires tremendous input of manpower and time. You can also be part of it and contribute to the innovation and technology in Hong Kong.
Let me study harder and become a thin film solar cell expert. I notice that in many public facilities and some private areas, such as the rooftops of some facilities or buildings, even the rooftops of village houses, solar panels are installed.
Solar panels are getting more popular in Hong Kong. We are aware of saving energy. Solar panels can convert sunlight into electricity. It can also block some of the sunlight and reduce the heating of indoor areas. There are 3 typical types of solar panels on the market. They are monocrystalline, polycrystalline, and amorphous silicon solar panels.
Silicon? Do you mean Silicon Valley? Let's go there if you want to travel.
Hey, it's nothing to do with traveling. I'm not talking about Silicon Valley. I'm talking about the chemical element silicon. Using different methods, we can synthesize silicon into different crystalline structures. Polycrystalline and monocrystalline are 2 different crystalline structures. Amorphous silicon refers to a disordered structure, which is non-crystalline. All these kinds of silicon can be used to produce solar panels. I have all 3 different types of solar panels here. The black one is a monocrystalline solar panel. The dark blue one is a polycrystalline solar panel. Both of them are rigid. The flexible one is an amorphous silicon solar panel.
I thought you were talking about Silicon Valley.
Not at all.
Let's do the experiment then.
Sure, let's go.
Wow, there are many wires. Will it explode?
Of course not. These experimental setups aim to test the 3 types of solar panels by measuring their output power under a stable illumination. Power is the energy output per unit time.
It sounds complicated. How do we do the experiment?
It's not that difficult. We connect the solar panel with these 2 wires, red to red, black to black. The energy generated by the solar panel is transmitted to the resistor. This resistor is connected to 2 multimeters. One of the multimeters measures the current passing through the resistor. The unit is milliamperes. Another measures the voltage across the resistor. The unit is volts. Power is the product of current and voltage, that is P equals IV. By multiplying the 2 numbers, we can obtain the output power of the solar panel. The unit is milliwatts. We will measure the output power of the 3 solar panels in turn. The monocrystalline solar panel is now connected. When the readings stabilize, you may record the readings. The numbers are multiplied to find the output power. The polycrystalline solar panel is tested now. Let's wait until the readings stabilize. You may record the readings. Let's test with the amorphous silicon solar panel now, then record the readings. Under constant sunlight, the output powers of the 3 solar panels are measured. In order to perform a fair test, the sizes of the solar panels are similar. They are placed under the same sunlight.
The monocrystalline and polycrystalline solar panels show similar results, but the monocrystalline solar panel performs a bit better. The power output of the amorphous silicon solar panel is much lower.
That is why more people use monocrystalline or polycrystalline solar panels.
Why don't we all use monocrystalline solar panels? Why are some people still using amorphous silicon ones?
Monocrystalline and polycrystalline solar panels are more expensive, especially the monocrystalline ones. But the monocrystalline ones are the most efficient. Due to their high production cost, large size, and heavy weight, they are mostly used in permanent solar power facilities. For example, if an array of solar panels is installed on the rooftop, monocrystalline or polycrystalline solar panels are preferred. On the other hand, for low-cost facilities, we may opt for amorphous silicon solar panels to lower the cost. Though their efficiency in power generation is not high, the production cost is low. They are flexible and light, so they are highly portable. They are usually used in mobile facilities. Among the 3 types of solar panels, monocrystalline solar panels have the highest efficiency. Monocrystalline solar panels can convert 10% to 20% of solar energy to electrical energy. That's why it's more popular now.
According to the statistics in 2020, about 31% of electricity consumption in Hong Kong is used for air conditioning. Most of the electricity we are using is generated by the combustion of fossil fuels. In other words, air conditioning leads to high carbon emissions. You have seen some methods to reduce the rise in room temperature due to solar radiation. Other than sun control window film, energy-saving tools also include semi-transparent thin-film solar cells and solar panels installed on the rooftops. Direct sunlight on the building is reduced, while electricity can be generated at the same time. These methods can reduce the use of air conditioning and thus the energy consumption and carbon emissions.